Hello everybody, in this one let's take a look at visualizing forming a sum between two variables x and y, so in other words a double sum. So let me just write the expression down first. Imagine that our goal is to find this sum, as for example x goes from 1 to 2, and also here y goes from 1 to 2. So the goal, and imagine the expression is x plus y, and we want to find the value. So again, this video is on visualizing this process and not just finding the value. I already have one on finding the value. So what I'm going to do is the following. First, we need to make some key observation, which is that x plus y is a function that basically contains two variables x and y. That immediately tells you that you got to draw two axes, label one x, label one y, and then when you add up x and y, that's going to give you a third value. That means you need a z-axis too. So this is a quantity involving two variables. So let me draw this over here. This is going to be my basically x-axis, this is my y-axis, and this is my z-axis if you like. Now let's draw some dashed lines that will represent constant values of y and constant values of x. So this will be a constant value of y equals 1, and this will represent the constant value y equals 2. Let's switch to a different color for the sake of variety. So say this will represent the constant value x equals 1, and this will represent the constant value x equals 2. Let's label this. So this is going to be x equals 1, and this here will be x equals 2. Let's also label this one, so this will be y equals 1 and this will be y equals 2. And then of course this is the x-axis, this is the y-axis, and then z is equal basically to x plus y. Now let's actually write the values of the sum at each combination of coordinates here. So I've zoomed in here at this point right here. Now here x has the value 1 and y has the value 1. So because our function says x plus y, I just have to draw basically like a little vertical arrow that represents the number 1. So I'm going to represent that by letting this arrow here represent the value 1 in the vertical dimension. When I move over to this point, here as you can see x has the value 1 and y has the value 2. So that means when I add them up it's 1 plus 2, which is 3. So I just have to draw an arrow that represents the right quantity there. So I can do that by making this one, say, bigger than the previous one, that way. They don't have to be perfect, just get the idea across. When I move to this point right here, here x has the value 2 and y has the value 1, which means when you add them, you're going to end up with the value 3. So here we have to be kind of careful and make sure that it's the same as the other arrow that has a value of 3 that it represents. So let's see here. I don't want to distort things too much. That's pretty good. So this represents the value 3, this was the value here 2, this was also the value 3. Now there's one last combination, which is this one right here. And here x has the value 2 and y has the value 2. So when I add them, I have to form the quantity 4. I've zoomed out here because I need to be able to represent that in the right relationship to the 3. So for example, 4 would be, say, this big arrow right here. Say that represents 4. And now we are going to basically form the sum. Let me just label this, that this is 4 in this position. And we do that simply by adding up the numbers that we see in an intuitive sense. So in other words, we can form the sum by doing the following. Take a look. This would be equal to, and then I simply just add up. So this will give me here a 3. So that takes care of this one, plus the 2 from there, plus the 4 from here, and then plus the 3 from here. So that's plus 3, and then you just add that up. It's just addition at this point. 12 as the value of your sum. And that is what we wanted to find. Because we have taken the time to construct a beautiful three-dimensional depiction of our double summation here, there's something else that we can do, which is we can use that picture to help us understand things perhaps in more depth. So specifically, take a look. Imagine that my goal is to form the sum across this way. See this? Or, for example, form the sum going this way. Can I do that? Well, I can. And this picture will help me to illustrate a little bit. This is what I mean. Take a look. For example, imagine that I formed a sum and going parallel to the y-axis, or in other words, setting x equal to a particular value like 1. Then my sum would become this thing. It would become y from 1 to 2, because I'm moving this way. See that? So y will first have the value 1, and then it will have the value 2. That's why here I have the lower index of 1, and then beginning with y equals 1, and then here it goes up to 2. But here when I move this way, x has the fixed value of 1. So for example, what that means is I can simply write my expression as follows. I can write 1 plus y, and that's it. Because x has the value 1. It's already fixed in there, you see? So then I can just go over the values of y, and when I do that, it's going to give me the following. It's going to give me 1 plus 1, and then plus 1 plus 2, and when I form the sum, this is 2 plus 3, which is 5. So for example, it tells me that the sum, when x has the value 1, going across the y's, is equal to 5. But you see that over here, because this is 2 and this is 3, you add them, you get 5. Let's do one more here. We're just exploring just to see what's possible once we have our, little three-dimensional picture. Well, it's a two-dimensional depiction of a three-dimensional world, so to speak. It's getting the idea across, though. You may want to pause the video and try this on your own. It's kind of interesting. So imagine that now I formed this sum right here. So again, here, as you can see, x has the fixed value 2 in this position. So that means I'm going to do it this way. I'm going to let y equal from 1 to 2. It's going to iterate over those values, but then this is going to become 2 plus y. And when I work this out, it's going to be 2 plus 1, and then plus 2 plus 2. I want to be clear on something here, that this is this position, and then this goes in this position. You see that? And in this context, when you form a sum this way, this green 2, that represents this fixed value of 2. So that goes in this position and in this position right here. I think color coding is kind of really helpful here. And then you just evaluate, so in other words, you add up the values. So when you do that here, you're going to get 7. And that's the sum when you iterate across the y's, keeping x fixed at positive 2. This is also again visible here, right? Because 3 plus 4 is 7 right here. I'm having so much fun. I love math. Let's do one more of these. So imagine that now I'm just going to fix the value of y at 1, and I'm going to basically form the summation going this way. So that tells you y has a constant value and x is going to change from 1 to 2. You may want to again pause the video and just figure out how to write the correct summation, but let me show you. So I'm going to have the summation here. For example, as x goes from 1 to 2. So those are the changing values of x. Let me emphasize that, right? This value of x and then this value of x. That's why this is 1 and this is 2. And then when I do that, that's going to give me, remember that y is fixed at 1, so I have x plus 1. So I'm going to iterate over the x's, keeping y constant at positive 1. When I do this, I will have the following. 1 plus 1 plus, and then here 2 plus 1. Work that baby out. So it's 2 plus 3, which is 5. That's the sum that way. And again, we already know this because as you can see up here, this value is 2. 2 plus that 3 is equal to this 5. So once you set up a little world like this for yourself, all kinds of little things that you can do that are kind of interesting, you can zoom in and then like really study things and so on. But that is it from me. Thank you so much for watching. Please leave a like and subscribe. It all makes a difference. I'll see you in another video.